All right, so welcome. This is the game development flow using Azure PlayFab. And let's get started. So in the agenda today, I'm going to give you an introduction about who I am and what I'm doing right now. Then I'm going to demo the game that I am developing, Grammar Wars, and then I'm going to do an architecture overview. And after that, I will be giving a small demo of the different parts and bits that the game is made of. So Unity Game Engine, PlayFab demo, Cloud Script demo, C# client demo, and potential improvements. I will try to pause in between demos in case you want to dig something or you have questions. I will give you the opportunity to ask me any questions, and I can dig into any part you're interested in knowing about. So the introduction, this is me. I'm Johan de Bruin. I'm a self-made programmer. The reason there is a bus icon here, it's because I did actually wanted to go to college and study computer science, but it's kind of hard to do that when you can't afford the bus fare that will take you to the actual college. So I just, learned by myself, learned programming, and I actually became a web developer. That was the thing that would pay the bills back in my small Spanish village, because the small restaurants, they wanted websites, and I'm like, yeah, I can do your website. And bit by bit, I became more proficient with programming, and in the last 6 years, I actually was working at Riot Games as a software engineer. I was building League of Legends ecosystems. The last year, I decided to quit to start my dream company. This is something I wanted to do for many, many, many years. And basically, I founded Riot Games. This is my Twitter handle, by the way, in case you're interested. And what we do is we develop free-to-play online educational games. All right, so I'm going to go ahead and I'm going to do a quick demo of the game. So the first thing, it's when you play the game, you actually see like a small spinner loading. This is because I'm actually fetching data from PlayFab. So most of the content of the game is actually defined server side. And it takes a second or two to download like the data files from the server. In this game, which is an English grammar game, I thought it would make sense to start there because I really needed help with the English grammar. You basically want to collect these cards, right? So the player has an inventory, and these cards, which is similar to Pokemons, you can equip and will give you stats. So attack, HP, recovery. So as you advance and play in the game, you will get entitled with these little minions. And these little minions, they actually have a level associated with them. For example, this one is level 2. Another thing that you can do with these cards, you can actually sell the cards for qubits, and that way you can have some sort of currency. So that's another thing that the player is entitled with, currency. And finally, there is a shop where you can buy wood chests or gold chests. This is in development, so sorry for the placeholders. But basically, you purchase the chest and you randomly get a loot, maybe a good card, maybe a bad card. And then, of course, you can buy the premium currency, I do need to pay the mortgage somehow, so I have to add some monetization features. All right, so this is the campaign mode. So the main objective of the game is clearing out these different levels, these different zones, and each zone is composed by different levels, and each level is composed by questions. So these are English grammar questions. So let's go and play the first level. And there are a couple of things that I want to mention here. The first thing is that the question that we display here is fetched from the server. So the client doesn't know a priori the question. You actually ask the server, hey, give me the next question for this level. And the answer, when you click on an answer, you can see that there is a small delay. That's because we are actually asking the server to verify the answer. So this means that the client, it doesn't really know what are the correct answers, and it needs to ask the server to process the answer, give me if it was correct or not, and once you kill the alien, the performance is also calculated in the server. So the client doesn't have that authority to be able to give you coins or give you the performance. This is important to keep a competitive integrity, because some of the features that we're going to add are going to be ranking systems and even like competitive arena modes. So yeah, so this is the big overview. Any questions so far? Well, I'm going to guess not. All right, so that's the overview of the game. And yeah. So I'm going to talk now a little bit about how I built this, the architecture. So for many, many years, I actually tried to do different prototypes. So this is something I wanted to do for over 15 years. And every time I had a Christmas vacation, every time I have some time off, I would just spend a couple of weeks trying a new technology and trying to see how that technology will serve the purpose of creating these educational games. So after trying so many things, I had to base my architecture in some principles. And the reason I chose the tech stack that I'm going to demo now is going to be based on these two principles. So the first principle is Robustness Path. I stole this principle from Discord, and basically it can read like a build quickly to prove out a product feature, but always with a path to a more robust solution. So this means not only that I should have a way to scale to 1 million players if it's required, but also I took this principle in the side of development, and I should have a way to scale. Like if I want to add an educator to help us with the questions, I should be able to give them a tool to do the questions. If I wanted to bring another artist, I need to give them a art workflow. If I wanted to bring like another developer, there should be like a path to develop unit tests and use GitHub and things like that. So that's the robustness path. The other principle that I use is frugality, and basically scope features to effectively use the framework, do more with less. This is something, a leadership principle that is used a lot in Amazon. And this can read basically, this is actually a luxury, right? So for example, when you are working as a software engineer and a product owner has this crazy idea, you normally want to negotiate with product owner to implement in a certain way that will cost like less hours to implement. In this case, I'm full stack, full decision driven based on the framework. Based on the framework, if the framework enables me to be able to develop a feature, that's going to have the priority. And that's what frugality means. I'm trying to use as much the framework I can, so I can develop features quickly and get to market quickly, because I'm not a huge company with 1,000 employees. It's just my brother and myself right now. This is very important. So using these two principles, I came out with this tech stack. And basically, I have the content. I actually defined them in Google Sheets. I found out that using Google Sheets, I can just write the levels, the questions, the inventory really quickly. And then I have a small C# broker client that will push the changes from the Google Sheets into the PlayFab database. Then Unity is just going to pull whatever data is available in PlayFab to define the game content. And then there is a small backend game logic that is powered by PlayFab. I will go through each one of these parts in the demos after. All right, so now I'm going to demo the architecture. So I demo the game, how the game works. I'm going to demo a little bit how it feels to make changes in the game. In this case, the objective is going to be to change the first zone name. So, all right. So this is one of the Google Sheets that changes the content. This is the actual levels that we have available. These are the zones. And in this sheet, I define all the levels. And in these sheets, I define all the aliens. So I'm going to go ahead I'm gonna do something crazy, right? I have here like 468 different aliens. I'm gonna go ahead and delete them. Let's go and define all these aliens one by one, shall we? So I'm gonna go ahead and delete all these levels. My objective is going to be regenerating the levels and the aliens, this time using a different name. So in this case, instead of Sputnik Launch, which is the name of the first zone, I'm going to name it DevOps Zone. All right? So the way I do this is I'm using a small C# client application. And it's very simple. It's actually just a command-based program. And it gives you different options. So if I want to like update the questions, tutorials, I can just do it one by one. Right now, what I want to do is regenerate the levels and the alien sheets. I'm going to click the option 100. And what it does, it basically connects to Google Sheets. It reads the first zone sheets, and using the parameters from the zone, it's going to regenerate the levels and the aliens using parameters in these columns. So you can see here that now we do have the DevOps zones 1 through 5, and we also regenerated the levels. At this point, a game designer, he can get into the Google Sheets, and maybe he say, well, the level 1 should have only electrical aliens because those are the easier ones to beat with the starter monster wildcard. So I'm just going to go ahead and change all the electrical aliens. Now I can use again this small C# program to update the zones, the levels, and the aliens in PlayFab. So I click free. And what this does now has download the Google Sheets from level, zones, and aliens and push them into PlayFab. So now if I go to PlayFab, this is the title data. This is the old data for the levels. It basically pushes a JSON file into this key-based database. You can see here that the levels are Sputnik Launch 1, 2, 3, 4. I'm going to refresh. And now we should be able to see the new levels. This is DevOps Zone 1, 2, 3, 4. Now this means that I was able to deploy a change to PlayFab directly from Google Sheets. And now the next time the player opens the game with the phones, they will get the new data for the zones. So now if I click, imagine that this is the phone. I click into the first zone. Now the first zone is called DevOps Zones. And there we are. We just made the change without making a deploy. Yay. All right, so that's it for the architecture demo. So far, how are you guys doing? Any questions? I'm guessing everything is okay. Maybe in the chat there is something.
So when you pull those from those sheets, you're just using APIs that the PlayFab has?
Yes, that's correct. I'm using an SDK. PlayFab gives you a C# SDK, and also Google Sheets. You can also get an SDK from Google APIs. So yeah, so I'm leveraging that, and I will show you that deeper later on. All right. Any other question? All right. Well, I'm going to continue. So now I'm going to go ahead and explain the 4 bits that builds the game. And the first one is Unity Game Engine, which is a flexible engine. It's ideal to building weird game concepts. Powered by C#. It's been over 10 years in development. Like they've been 10 years releasing new versions and improving it. It has a big community. And it's prevalent in both in the indie and professional studios. And the good thing is it can export to many platforms, console, PC, web, you name it, they got it. So I'm going to go ahead and show some bits of Unity client. I'm going to focus on the part that connects to PlayFab, but for those who are not very familiar with Unity game engine, is basically similar to Visual Basic, where you can use visual cues to develop the game. You develop through these things named components, and there are both components that are made by Unity and then components that you can create through code. And and probably the only big part is the fact that you can pre-generate prefabs, and those prefabs you can use them to instantiate new elements in the game. So for example, here in menu button, I can go ahead and design like this generic button, and then using code I can change and generate new buttons if I need it. So that's one thing. Another thing that I want to show is the fact that you actually have I install a Unity SDK, so a PlayFab SDK in Unity. So PlayFab develop an actual SDK for Unity game engine that you can install, and then it gives you like different options through both a library, but also UI to interact with PlayFab. So in this case, for example, I'm able to choose like the title I want to work with. So for example, right now I'm working with the development environment, but I can change the title and develop against the beta in case I want to test something in the beta server. Maybe there is some logic that I deployed a couple months ago that is not working and I changed it in development. I can just swap the titles here and debug the player experience from the beta. So that's something pretty cool. All right, so that's it for that part. Let's go ahead and show some code. So I'm gonna show like these connectors. I have this static class that I use them as data access objects. And basically what I do with them is each one of these connectors, they will interact with PlayFab in a certain way. In this one, for example, is in charge of getting the title data. Title data is a PlayFab mechanism, and basically you can fetch data that is global for all players. So the list, the level list, the list of the aliens, the list of the zones, the skills, things like that. I can just fetch them. They're gonna be the same for all the players. And this is the way you interact with PlayFab. Once you install the SDK, they will give you access to this class, and you can just call different methods through it. In this case, I ask PlayFab, hey, give me the title data. It's key-based value-based, similar to NoSQL solutions. So I can just ask for all the keys of the data I want to retrieve, and then it just call a callback once you get the results. And in this case, I'm using this generic method to be able to parse the data from a JSON into an object using reflection. So this is for title data, and I have another one here for the player data. So this is similar. Again, I'm using the PlayFab API, but this time I'm calling the get user read-only data. And this is basically data that the user can only get, but he cannot change. There are different types of player data. And this is things like, the player team, the tutorials that I display to the player, which levels he has cleared. This is data specifically for the player. So I wanted to show that extension. And even though the way you retrieve it is very similar to title data, the way it works is very different. The other way you can interact with PlayFab is through these cloud script functions. And this is basically endpoints that you call if you want to execute some sort of server-side logic. So for example, if I want to say PlayFab, hey, I want to start a new level, I execute a cloud script function and I pass a parameter. I'm telling, hey, PlayFab, start the first level for me, please. And then it will respond with, the level is started. Go ahead and start playing. So yeah, these are the three main ways I actually interact with PlayFab. One important thing that I wanted to show off is the fact that I have this small folder named DTO, And this DTO folder defines like classes that I use to interact with PlayFab. So I like to separate this from any other logic in my code, because that way I can remember that if I change any of these classes, I need to be very careful to also change it in PlayFab. Otherwise, it's going to break, right? There is going to be a mismatch in between, like the name of the attributes or whatsoever. To follow up that principle of path of robustness, maybe in the future I can have like version DTOs or version endpoints. That way I'll be able to deploy changes without breaking the previous changes. But right now I'm not doing it because I don't need it. And the last thing I want to show is this wrapper. So I don't like my game and my game components to call directly the PlayFab classes, because it's kind of coupling my data access with my game logic. So I created like these wrappers, and they are basically interfaces that I can call through an injector, and that way in the future I can substitute these injectors in case I want a unit test, or I can create an interface that retrieves mock data in case I want to develop against mock. A little bit of Liskov substitution pattern here. Yeah, so this is what I wanted to show from Unity perspective. There are any questions for Unity? I know there is a lot, so there should be one or two questions. Oh, I think there is one in the chat. I missed the first 20 minutes of the talk. Okay, Diana, what is your question? Looks like Diana has a question, maybe. Oh, so what's the role of PlayFab? So basically, PlayFab, it's kind of like a game content. It's what handles the game content, and there are different roles that PlayFab fills. One of them is basically you can use it as a database to retrieve the data, and also you can use it to run server-side logic. And actually, that question is a good transition for the next step. So let's go and explain PlayFab. So PlayFab is a backend as a service for games. It also can be used to create gamified apps. It's owned by Microsoft, and it does have SDKs, different technologies, so you can use it for different technologies. So for example, some of the features that PlayFab handles is it handles the content, it handles authentication, it handles the economy of the game, entitlements, server-side logic. You can add features like friends and clans, matchmaking, or analytics. Let me go ahead and show PlayFab. Okay, so if you go to this PlayFab, here you can see like a bigger screen of the different titles that you have in the game. In this case, I'm going to click on Grammars Wars Dev, and here I can see an overview. So basically, you can be kind of like a big brother and see how many players are playing the game and what kind of stuff the players are doing, right? So for example, as a game designer, I can see how much the players engage with the game and maybe make decisions based on the analytics. I did that a lot with the beta, and I did change a lot this version based on the data that I was able to gather from PlayFab. One of the main things that I'm using PlayFab right now for is to actually retrieve and store the content for the game. This is a good idea if you want to iterate the content on the game quickly. So if I want to change the questions, I deploy them to PlayFab, and then the game will download it from PlayFab. And that way, I don't need to update the game from the player's perspective. They don't have to go to the App Store and update the game if I want to just change questions. So this is, for example, some of the title data that I was mentioning before. And I also have like this internal data where I store the questions. I don't want some hacker to be able to sniff my PlayFab communication and just get all the questions that we wrote for the game. Mainly because I don't want them to know the correct answer. So I store them as internal data. That means that only my game server logic can access to it and not the players. Another thing that I want to show is the economy tab. Now, I'm just showing some of the features that I'm using for Grammars Wars, but there are a lot of other features. Like you can implement real-time multiplayer, you can implement groups. One of the features that I use a lot is the catalog. And in catalog, I basically have the ability to define each one of the cards that the player can get entitled with. And even I can define like custom data for that card. So I can define things like what is the ID of the card, what is the display name of the card, for how much the player can buy or sell this card, and even the statistics like how much health points, attack, recovery, HP, and things like that this card has. So again, if I want to change the statistics of the cards, like for example, I want to do some balancing, there is a card that is way too powerful and is killing all the aliens too quickly, I can make the changes in PlayFab, and then the player will get the changes deployed without any kind of update. Perfect. So that's for the catalog. And one of the most powerful environments that PlayFab has is these players, where I can actually check players' statistics. So right now, this game in development only has one player, myself. And from here, you can have access to different views of how the player is doing. One of the important things is this one is the identities. Oh. So one important thing that PlayFab handles is the fact that you can authenticate from different parts. So for example, let's say you connect from the phone, and then you link the phone to Facebook, and then you play from the web, and you also link the web to Facebook. PlayFab can connect both devices and use the same player for Facebook, for web and mobile. And that's kind of handled by PlayFab side. There is not too much overhead you have to implement, which is pretty cool. So now I want to show like the inventory. So there is a catalog, which is everything that the game can have, and then there is an inventory, which is which items from the catalog the player owns. And one cool thing about this is that, for example, the tutorial run, this card did have like these base stats, right? The inventory from the player can also have custom data associated to this particular instance. So for example, the cards does have statistics here defined in PlayFab, but I can also define how much experience point this card has. That way I know that this card has 40 experience points, which equals to level 2. Right in it. And the most important part is the player data. And again, there are different scopes that you can define the player. You can define the player data using just player data. This is basically data that the player can change, good to be used for things like settings. The read-only data is data that you want the player to be able to read, but not to change. Only the game server can change this data. So for example, here I use it to show clear level IDs, display overlays and things like that. And then there is internal data. This is data that only the server can read and not the player. And I use these to keep track of the player's progress. For example, from the demo that we played before, we left in the question of a concrete noun. And here the server does know which are the correct answers and the incorrect answers. So I get the info, I keep data about the questions, I keep data about the current game, like how many aliens I have to kill to finish the level, how many coins have I granted to the player, and what was the performance, the overall performance of the previous questions. So for last thing I want to show is this Cloud Script tab. Basically, these are the different cloud functions that I mentioned, the server side. So for example, I can call game start here. And this is a good tab if you want to run like integration tests. So if, for example, I want to test just calling, starting a new game. And in this case, I'm gonna put something weird. I'm gonna put like a level that doesn't exist. It's gonna throw me an error, and I can get some of the stack trace of the error and see what the hell is going on in case I want to debug. In the other case, if I actually put a level that does exist, the function will go succeed. So if I'm doing backend development, I'm not doing any kind of client-side code. This is what I will use to test that my cloud functions behaviors are working correctly. Any questions so far about PlayFab?
Hello?
Hello?
Are you using the multiplayer, or are you just...
No, I'm not using multiplayer. It's a little bit... yeah, I'm not using the real-time multiplayer. I'm using kind of like leaderboards. So I'm ranking players between each other. And I did try the groups, which is kind of like to create like friendships or to create clans and guilds. I never yet used multiplayer servers, which is real-time multiplayer. And PlayFab has the ability to spin up a Unity server and do like a real-time physics-based multiplayer if you want to run like a FPS game or if you want to run like real-time strategy game. But because my kind of games is all asynchronous online, I'm not planning to use this feature anytime soon. But if you want to, you can even use Photon. Like Photon is a very popular library to do a real-time multiplayer. And Unity has an add-on. By the way, this is one of the cool things about Unity. You can install like different add-ons. And one of them is Photon. So if you want to do real-time multiplayer using Photon, Unity has an integration with it. You know if Filament uses PlayFab? I asked them if they were planning to add any kind of online features to RoboCoco, which is the latest game that they're developing. And they mentioned that they didn't have an engineer like me that could handle that kind of systems. So I'm guessing if they didn't find another a substitute, no, they probably are not using PlayFab. Yeah, well, I might maybe in the future. Maybe if this Grammar Wars business doesn't work out, I'll go ahead and that would be neat. Any other questions? All right. Well, then I'm going to continue. So now the third part that I want to show is the Cloud Script framework. So this is all kind of like a small custom-made framework that I built to run those server-side logic within PlayFab. So it's similar to Lambda or Azure Functions. I made a custom solution using Node.js. And that custom solution, I built it so I could separate the code through different modules. Also, it will allow me to use TypeScript, and finally, I can decouple the modules using dependency injection. Yeah, and I can run unit tests using Jest. So let me show you what I'm talking about. So by default, when you want to add server-side logic using Cloud Functions, you can click on the documentation tab and click on revisions. And this is basically how you interact with PlayFab if you want to have server-side logic. You have to define like all your code in a huge JSON file, and that's it. That's how you work with it. You cannot like separate the files. You cannot like run the code. You have to deploy it and then test it with TypeScript. After I got to 500 lines of code and I spent like 3 hours changing a variable name, I decided that I needed to build something to make my life easier. So I built like this Node.js framework to handle CloudScript. Yeah, and basically it's kind of like a Babel or transcompiler that. Well, I'm basically using the TypeScript transcompiler to be able to unify all the files, and then I do a small magic in the build. And you can see here the different things that I'm using. So this is how the main TypeScript looks like. And the way it works, PlayFab works, is it exposes. By the way, this is JavaScript, but it exposes like these handlers global, and any property that you add to these handlers, it will become a function that the player can ask. So in the main TS, what I created a small controller, similar to the controllers that you can see in frameworks like Java Spring or Express, where I call the different services in my game, in my logic. So you can see here on game start, I call in the game service. In fetch the next alien, I call the game alien service. So there are some limits, something I didn't mention before. There are some limits on how much you can use PlayFab for certain things, and once you hit those limits, you have to pay extra. One of the limits, if you want to use the free version of PlayFab, is that your script needs to be like, I don't know, like 10,000 characters or less, or 100,000 characters or less. I can't remember. But you need to minimize the number of lines of code. So I handcrafted like this small service locator, has a dependency injection, and I found this in a book about JavaScript patterns. It's like 20 lines of code, but it's pretty cool because it does make the job. So let me show you a few of the services that I use. So for example, this is the title data service, and I use this service when I want to get any of the title data that is global to all players. I actually cache it. That's another thing. There are some limits on how many times you can call the API in a Cloud Functions. So when I get some title data, I actually cache it in this class. And next time I call it, I just use the cache instead of calling again the API. And actually, I don't flush this cache, but this one, the player internal service, when I want to get some information about a certain players, I actually cache it as well, because if I call getting the inventory of a player twice, I don't want to do it twice in the same script. But in this case, I actually clear it. I do clear it. And the reason I do this is because PlayFab spins up, I think it is right now it spins up a Lambda function in AWS. I know they're migrating to Azure because they got acquired by Microsoft. But the way Lambda functions works is that when they spin up a certain function or they execute your program, they analyze the rate of usage. And if they can anticipate that your function is going to be reused, they don't actually tear it down. They keep it up for the same player. So this is a little optimization. The first player that calls the service will have to download the title data and cache it, but the next players, they will reuse that cache. So this is something I learned actually working at Riot. It's a very common pattern in this kind of microservices. But I kept the pattern. But I do need to clear the cache for the players because then I get a lot of weird bugs. Another thing I wanted to show is these game stats. This is just a plain object, and I just expose different functions. Again, I'm trying to decouple the game logic from the actual services, and this is logic that calculates, for example, the answer performance or the question performance or things like that. And the cool thing about this kind of pattern is very easy to unit test. So if I want to unit test setting up the last player performance, I can just run this unit test and totally. I can just actually, let me show you. Come on, git bash. All right, so yeah, I can do npm Bruin test, and it will run my unit test, which is neat. Because a lot of times there is some complex logic that doing the integration test using cloud scripts can be tedious. So that's something, yeah, that's it, what I wanted to show about cloud script. There is any questions about cloud scripts or about server-side logic that you would like to know? Let's see, active. No questions. No questions at 3, 2, 1. All right, that's it. Now the last part I want to show is that C# client. So basically that program that I used before to broker between Google Sheets and PlayFab. And I know there was a question before about what I use. I use Google APIs libraries and PlayFab C# SDK. So let me show you some of the code. It is here. So this is pure console application. I'm using .NET Core. I think that means that it can run on Linux. I don't know. You can see here that I'm using these two packages, Google API Sheets and PlayFab SDK. And yeah. So let's see. The program, in very simple entry, I just print the options when I initialize the different the PlayFab system and the spreadsheet systems that I use, and then I print the options. And basically, I ask the player what he wants to do, and based on the answer, I will just call one of the different modules. So because each Google Sheet I interact with is structured differently, and it does generate different type of DTOs. I actually separate the different modules into based on the type of sheet that I interact with. So for example, this is the spreadsheet locator where I define and initialize a spreadsheet broker for each one of the spreadsheets I work with. So this is the initialize functions I call the main. And this is the code of a spreadsheet broker. And it's basically a generic way to be able to connect to a spreadsheet, get values, get the ID of the sheets, and update the values in the spreadsheet. That way I can use the same broker class with different spreadsheets. So let me show you, for example, the class to fetch the module to fetch the levels. Basically, yeah, I use a lot of custom code. I basically get the values and I process them. Pretty much a data mapper, data structure mapper, where I map rows from a Google Sheet into the data structures I need. And once I process it, I call this PlayFab process broker to save the title data. So for example, here I'm saving the zone list, and here I'm saving the level list. Similar with the questions, I will go ahead and generate questions from a certain broker, and yeah, that's what I do. I mean, any questions with this C# client? I want to know more about how I connect to Google Sheets or how I connect to PlayFab.
I'd be interested to see more about how you're interacting with the Google Sheets.
Okay. So that's the, I basically encapsulated all the logic with Google Sheets with the spreadsheet broker. And basically what I use is this Google APIs SDK. I actually pull it from NuGet. So this is the library that you want to download from NuGet. And the way it works is based on OAuth. So you need to enable I remember doing like some API setup. I downloaded this client secrets.json that I don't want to open because it's secret. But basically, once you generate those using the Google API console, you can just connect to different spreadsheets, and this is kind of like the code I've used. If you want, I can send in the Slack a link to a YouTube video, which is the tutorial I use to learn how to connect to Google Sheets, honestly. But yeah, basically the way you do it, you open a connection with a sheet service. So this is when I create the spreadsheet brokers, that's what I do. I connect to the spreadsheet service. And once you are connected, you have this service connection. You can just call one of the different API gets to get data. So for example, here, I'm calling the spreadsheets class values and get to get the actual spreadsheet. And you can just pass a range of what kind of, what's the range of the actual spreadsheet. So you can range columns and then it will just grab every row that has data on it. So that's what I do, for example, when I try to get the levels here. I'm asking to get the range from A to G, or well, in this case, A to C, because I don't need the other ones. I grab all these 3 columns, and then Google Sheets API will give me all the rows that has data. So he will give me all this, and it will not give me a row 13 or 14 because it's empty. And that's it. And once I have the rows, then I just have to process them. Oh yeah, the rows that they retrieve, they also have, it's a list of lists, right? So there is a list of rows, and each row is a list of cells. So I just go through the cells, and I for example, grab the first cell from the row, the second cell from the row, the third cell from the row. And this is a little bit of magic. I know that the first cell is the ID of the zone, the second cell is the name of the zone, and the third cell is the description of the zone. And once I process it, I save it all in a list of zones. And this is actually what I save in PlayFab using the PlayFab broker, which is another SDK from PlayFab. Other questions? Did that answer your question?
Yeah, I think I was kind of looking to understand if you were, using your own authentication, if you were having people give access to your app.
No, I'm using my own authentication, which is here in client secrets. The only thing that you also have to do is to be able to connect to these Google Sheets, you need to share it with a C# client. So here is, for example, what I had to share it with this fake email, and basically this tells Google that my program is authorized to connect to Google Sheet. This is what I can show you. And this is defined in that JSON secrets file. That this is something that Google gives you once you create a Google API account. All right. There is any other question?
I noticed you're using Rider. Is there something specific to Rider that's good for game development, or is it just your personal preference?
Yes. So actually, Rider, they put a lot of work to make it very compatible with Unity. That's one of the reasons I use Rider. It has a lot of features that, for example, it automatically detects the unit editor and attaches the unit editor. You can also run the unit test from Unity from Rider. And the code detection from Rider works with the magic component systems from Unity. So, for example, sometimes it will tell you that I should, like this serialized field is a what do you call these things? Well, a flag that you use only for Unity, and if you change it to public, it might suggest me that I should change it to the serialized field. Or it tells me, oh yeah, it doesn't suggest it to me, but for example, it gives you indicators of which prefabs or components this serialized field is being used by Unity. So this is an option that I defined in the Unity editor, but Rider is powerful enough to know that the editor uses that serialized field. So that's why I use Rider, because it's the best IDE, in my opinion, to use with Unity. But it's also a very good IDE. I mean, I don't know. Which editor do you use?
At work I use VS Codes, and then at home I have Code and Visual Studio.
Yeah, VS Code actually. I've been thinking about using VS Code because PlayFab, it's actually working with VS Code heavily, and there is like an add-on that you can use in VS Code to directly execute cloud functions from the server. So if you want to debug cloud functions, you can use VS Code. But that's a feature that is on preview. And probably Rider will implement it too eventually, because they want to make sure they don't lose clients. Anyhow. All right, I'm gonna go to the last part, which is just making references on some potential improvements that I could do. So, for example, I want to allow teachers to create groups, and now a teacher should be able to create a group and then add players to that group, so all his students, and that will allow them to keep track of the progress of the class. And even I could allow the teacher to alternate the campaign learning objectives in case they want to adapt the difficulty based on the class. So that's a cool feature I can implement with PlayFab, and I can do it fairly quickly because PlayFab gives me all the tools I need. Like it gives me that group capacity and that shared environment where a teacher can share data with the students. I want to migrate CrowdScript to Azure Functions. This is a new feature that PlayFab has on preview, but basically it will allow me to debug CloudScript behavior directly from my computer. So I can hook up a cloud function and tell PlayFab, hey, don't execute this in your server, execute it in my computer, and I can actually receive traffic from a player and in real time debug the code, which is pretty amazing. Maybe also I might want to migrate the C# client to Azure Functions. So right now, every time I want to deploy something from Google Sheets, I actually have to execute a program in my computer. It would be neat if I can use Azure Functions and add some sort of hook and that detects every time there is a change in Google Sheets and executes a function. And another neat thing, it will be maybe create another Azure function that every time an Azure function deploys a change to PlayFab, it can also commit a JSON backup file. And that way I can have a backup of any changes we do in the Google Sheets. And even this could open the door to create comparative versions of the game and do some sort of A/B testing, which I know PlayFab also has a feature. So yeah, that's it. Thank you very much for coming over here and listening to me. If you want to contact me, these are my handles, my Twitter, my email, and we also have a YouTube channel. I'll probably update this video over the YouTube channel in case you want to review some of the stuff. I can open for any last questions you may have.
I'm sorry, how long did you say you'd been using PlayFab?
About a year. Basically, I started using PlayFab when I started to prototype my Satopolis game, which was on February last year. No, February last year? No, sorry. November last year.
For the stuff that you were learning, did you primarily, I know you referenced YouTube for the one thing, is that where you're finding a lot of stuff? Is on YouTube, or are there certain tutorials you really like or anything like that?
Oh boy. I did this. I went to playfab.com. Like there is not too much information in YouTube about PlayFab, unfortunately. So I did this. I went to PlayFab, I click on documentation, and I read this whole thing. I just went page by page, and I start reading, page by page, and I start reading. That's what I did. Which is, sufficient. And there are a couple of videos you can use in YouTube as well to get started, but they will only give you like the surface of what PlayFab can really do. And it's just mind-blowing of what the hell PlayFab can do. Like, there are so many features. And the good thing is that every feature they release is pretty generic. Like, they don't give you a solution, they give you like a framework to be able to build many different things. So for example, the groups. In groups, there is a mechanism named shared groups. And for example, if you want to create a turn-based strategy game where one player has a turn and then the player 2 has another turn, you can create a shared group, and it's kind of like a data structure that only 2 or 3 or certain players can access to. So they name it like that, shared groups. But, it can be used to create turn-based strategy games, or it can be used to share data between a professor and his students. It can be used in many different ways. So that's the beauty of PlayFab. And actually, I will evangelize this, and I will use this not only for games. I will use this to do even social apps or gamified solutions, because it will save you a lot of time building from scratch or even building using frameworks.
How does the pricing work for some of this stuff?
It's very generous. I've been using PlayFab. I released 3 titles so far. Well, two games. Grammar's War has like 150 active players right now. The beta, by the way, if you want to play it, you can access it through grammarswars.com. And I also released Cytopolis, and I'm not even close to hit the limits for the free tier. And basically, you can use the free tier and get up to 100,000 players playing in a certain game. And only when it hits those limits, it will start charging the standard plan, which is $99 per month. Now, I suspect that, it's... and as long as you are frugal, as long as you use the limits in a smart way, you can get away with the $99 plan and have millions of players. And then once you hit the limits, like if you use PlayStream events, like more than 20 million events, it's kind of like $6 per additional million. But again, there is no reason you should hit these limits if you code in a smart way. You use those caching systems. You are a little bit smart and wary of what the hell you're calling against PlayFab. Yeah, and there is always the risk of they changing this in the future. It happens, but the good thing is they're backed up by Microsoft, and one of the cultures of PlayFab is trying to get this kind of infrastructure available for indie devs. Getting this kind of infrastructure is really expensive. I know because I used to work in a company that was building this kind of infrastructure, and we're talking about millions and millions of dollars. So yeah. Any other question? Chat. Well, if there is nothing else, I think I'm going to wrap this up. Thank you very much for coming and listening to me again. I really appreciate it. It's been lonely.
Thank you. Thank you very much.
Yeah, thank you. This was
my pleasure.
It was interesting.
Yeah. And if you want to know more, you feel free to contact me. I love talking about this stuff. So.